continuation of part one. This is probably the most difficult problem is when they don't have the same base. Okay, what do you do with problems that don't have the same base and you're trying to work with their exponents? What you have to do is you have to change the base. So you have to look at these numbers. You have to look at 81 and 9 and say, okay, how can I write this as an exponent? So you can say what numbers make them both. So if you have to really know your exponents. So you have to know your powers of 2, your powers of 3, powers of 4. These are probably the most important. Powers of 5 are good too, but these will probably help you out the most. So for example, 2 to the second power is 4, and then 2 to the third power is 8, and then 2 to the fourth power is 16. 3 to the second power is 9, 3 to the third power is 27, 3 to the fourth power is 81. So 4 to the second power is 16, 4 to the third power is 64, and then the other one is like 200 and something. I'm just losing track. 5 to the second power is 25, 5 to the third power is 125. So you have to know what happens as you keep multiplying by 2. So 2 squared, 2 thirds, 2 fourths. 3 squared, 3 thirds, 3 fourths. Now in this case, it's the 3, right? You see that? 3 makes both of them. So if you think about this, this is 3 to the 1 power. This is 3 to the second power, 3 to the third power, and 3 to the fourth power. So you kind of have to know those. What that means is this one can be changed to 3 to the fourth power. So I'm going to rewrite this problem, but this is going to change. It's going to be now 3 to the fourth power. 9 is also going to change, but that's going to be written as 3 to the second power. Okay, but what about the exponents that are already there? These exponents you leave with the new one. So this has an x plus 6, and this one has a 4x. Okay, now what's the point of this? Well, if you're trying to solve this problem, now you know that the 3's are the same. You can kind of ignore them. You can ignore the 3's, and you can just focus on your exponents. And now it stops being an exponent problem. It just becomes a regular equation. So if you're going to multiply this, you're going to have to distribute, right? So this would be 4x plus 4 times 6 is 24. And 2 times 4x would be 8x. Okay, there's 2 x's on 2 different sides, so I can't just add them. I have to move one of them. So I'm going to move this one, cancel it out, and move it over here. Okay, so this will leave me with 24 equals 4x, and then divide both sides by 4, and I get x equals 6. That's my answer. So what does this mean? All right, well, if we go back to the original problem, right, this. If you put 81, 6 plus 6, what did I just do? I replaced the x with the answer 6, is equal to 9, 4 times 6. So if you combine these, this would be 9 to the 24th power. And this would be 81 to the 12th power. And if you put those both in your calculator, you will get the same answer. You'll get the same answer. I'm not going to do that right now, but that's kind of that's how you would double check it. Okay, the answer is 6, and you would double check it by plugging it in. That's how you would do it.